All right. Let's go with purple today. Yeah, it's a good one. Okay. Nice. Hey Milo, how you doing, man? Can you hear me? Hello.
Hi.
How's everything?
Good.
Good. How was your week?
Good.
Did you guys start any new things for math?
No, we're still doing two-step equations.
Just still two stuff. Okay, that's good. Those are easy for you, right?
Yeah.
Okay. I guess we'll just slow down. We don't have to like go super fast. And I guess for like these couple, like I guess in the next few weeks and month, I'll probably just go over like radicals again, and then just some algebra expressions on rationales. And do you remember last week we did the graphing a line equation, slope-intercept?
Yeah.
Okay. I'll probably do something similar to that today, and maybe like there's another form. So like that slope, the one form I showed you. Do you remember how to find the slope and the y-intercept, right?
Yeah.
We'll review it, but like there's another form they call that standard form. But yeah, so I'll introduce that today because a lot of times they typically ask you if you can convert one over from one to the other. So that's a good thing to cover. And yeah, we'll just cover that again, and maybe I'll look into like what we could do for like word problems, because I know with in the beginnings of algebra, you learn the math, but then eventually you're gonna want to do like apply it in a word problem. So we'll probably do that in like 3 weeks, but we'll keep on doing this. Is that good?
Yeah.
Okay. All right. Okay. So I guess I don't know if we did these ones because there's like no markings. But like let's look at number 13 here. Actually, this is kind of fair. Let me use another color. Orange. Oh no. That one's the same as the other guy. Yeah, I think this is a good color. Okay. Okay, so let's try do number 13. Do you remember doing this?
Kind of.
Okay. Let's just cover it again, just like basics. So like when you have this radical is a come on. This radical is when you have something at the bottom, something like this, something like this. Oh, do you remember you just have to multiply it by the same thing in both the numerator and the denominator?
Yeah.
Yeah. And then eventually what ends up happening is you only get this at the bottom, right?
Yeah.
And it's this guy. So let's do that a couple of times, just like get everything set and warmed up. So what's the very first thing you need to do with this guy?
Multiply it.
Okay. Oh yeah, like for this one, it's a little when they give you something like this, you see there's an x squared here,
Yeah.
and then what's the square root of x squared?
X.
Yeah, so you can actually take that out first. So what I would do is maybe like yeah, let's rewrite it here. So let's see, you have this minus 3 root 3 x, and then since you have this one already, you take the square root, you can just take it out. So it's like 3x root 3, right?
Yeah.
Okay, so now you do what we just talked about. So you multiply top and bottom by this radical, right?
Yeah.
So root 3 over root 3. And that's really the rule. Every time you see something at the bottom that's in a square root or radical, you always multiply it like this. So now you distribute this guy, right?
Yeah.
So let's say root 3 and minus 3, and then you have root 3x, then root 3 over 3. So this 3 becomes 3 times 3. So that's just 9x. Okay. So what do you do at the top?
Combine like terms.
Yeah, this guy. Okay. So it's 4x cubed root 3. You can't really do anything with that one. But in here, you can do something here, right?
Yeah.
So minus 3. And then this root 3. What is that? Root 3, root 3. Root 3 times root 3. That's just 3, right?
Yeah.
So that root 3 times root 3 is just 3. You times it by 3. But you still have root x, right?
Yeah.
So that's it. And then you just simplify. So it's 4x cubed root 3 minus 9 root x over 9x. And sometimes when you see something in like outside the radical, if they simplify, you can cancel. But in this case, they don't simplify. So you could just leave it this way.
Yeah.
Yep, and then that's pretty much that. I think doing this is it's just a good thing to really hone the skill of like doing this really fast and then doing the rational exponents really fast. Okay, let's try doing this guy. So what's the first thing you need to do?
Multiply.
Okay, so this guy at the bottom, right?
Yeah.
Okay, so let's see. Before we actually do that, again, so you see this bottom thing here, the k cube.
Yeah.
You can take out something from here, there, right? You can take out something from k cube to make it k squared inside.
Yeah.
So it's this guy. Let's see. So you have root 3, and then you also have k times k squared, right?
Yeah.
So what's root of k squared?
K.
So it's just k. So that comes out, and then the only thing you have inside is root 3k. And everything up top, I'm just going to rewrite it because we're not doing anything there yet. 3, 2, and k. Okay. All right. So what do you do now?
Combine like terms.
So before we do that, what do you do with this root 3k? What do you do with this guy, the root 3k?
Do you put it to the top?
It's a root at the bottom, right? So what's the rule there? You have a radical at the bottom, so you have to times it, right? Yeah.
Yeah.
Top and bottom, right?
Yeah.
So times it top and bottom, and then so the bottom first. What happens at the bottom? You have k times root 3k times root 3k. So the radical disappears, right?
Yeah.
So it just becomes 3 k squared, I believe. I think up top something's gonna cancel up top. Let's just see. So you have, so at the top here we have to distribute this guy, right?
Yeah.
Let's see. Let's just do that first. Let's not skip steps. So root k4 times root 3k plus 3 root 2k times root 3k. Okay. So now what do we do?
Now you combine like terms.
Okay, good. So now you could do the first one. So let's do 5 times 3. And then you do k to the 4th times k plus 3 root 2 times 3 times k times k. All right. So you have these exponents inside. What do you do when you have exponents being times and multiplied? Do you add them?
Yeah.
Okay. So that's just a review. So you add 4 plus 1. And then the 6 here. And then this is 1 and 1. So that's what? Squared, right?
Yeah.
All right. So 3k squared. And then see, let's see if something happens. And then if you can take something out. So this k to the 5th. Can you take something out from this guy to make it like cancel with the radical? 15k squared, right?
Yeah.
So you can split that 15k squared times k to the 3rd, right?
Yeah.
Okay, so plus 3. What about this other guy? This k squared. It goes outside, yeah. And
Yeah.
it becomes k. Okay. So it's 6 now, root 6. And let's just rewrite the bottom. Okay, let's see what happens. So this k squared, you can take this guy out now, right?
Yeah.
Actually, you can take a lot of things out. Let me think. K squared. You could actually, this k cubed. Let me go back. So this k cubed can be split to k squared and k, right?
Yeah.
So you can actually take out a k squared, I believe. So you take out a k, and you take out another k. So it's k squared, right?
Yeah.
Does that make sense?
Yeah.
Okay, so 15. Yeah, I'm just doing some shortcuts here. So 15k, and then plus 3k root 6, and you have 3k squared. All right. So let's see what we have to do here. So you have 15k, 3k root 6, and over 3k squared. Can you cancel anything?
The 3k or the k cubed, k squared.
Yeah. So the k, right? So k can come out, right? So when you do this, like k root 15k plus 3 root 6 over 3k, right?
Yeah.
And the k is also at the bottom. So you can cancel k, right?
Yeah.
So that becomes 1. And your answer is k root 15k plus 3 root 6 over 3k. Not bad. I like doing this kind of stuff. What about you? It's not that bad, right?
Yeah.
Okay. Yeah. Have you guys haven't touched any? Have you guys done two-step algebra equations with radicals?
No.
Okay. Only integers and variables, right?
Yeah.
Okay. Yeah. So like knowing this ahead of time is good. So let's do number. Okay. Then where's the variables? Oh, the variables disappeared. Yeah. It's always good to do the ones with variables. Okay. Let's just do one more variable and then we'll do the one with division. All right, let's do this guy. What's the very first thing you need to do?
Multiply.
So like the same with the other ones, you want to look at like the x and the y. Like before you even do anything, x and the y, is there something there you can take out the radical? The y, right?
Yeah, the y.
So what can you do with the y?
Put it in the, multiply it by the whole equation.
So it's y cubed. It's y cubed, right?
Yeah.
And then what can you do with the y cubed? You can split it into what? Y squared and y, right?
Yeah.
That makes sense, doesn't it? Like y cubed can be split into like y squared plus 1, right? Yeah.
Yeah.
Y squared and 1. This is just reversing the exponent rule. So you always have to do that with these ones because it's like a trick where you can't move on. You could just times it by exactly the same thing. It'll cancel out, but it's easier to do it this way. So you have this 10x y squared y. What is the square root of y squared? What's the square root of y squared?
Y.
Okay, so let's see, root 15xy, and then 3. So you can take it out of the radical, right?
Yeah.
So it's gonna become a y, and then what is left inside the radical?
Y.
The whole thing, 10 times.
10 times x, y.
Okay, good. Now what do you do? What do you do now with this thing?
Multiply them.
By the radical, right at the bottom.
Yeah.
Okay, so you multiply it by the whole radical, xy root 10xy. All right, so now we have to simplify. So 3y, and then this the bottom, it just can't. You just cancel the radical, right? It's just 10
Yeah.
times xy. So
Yeah.
10 times x times y. Okay, and then I'm just gonna rewrite the top. 15 xy times 15 10xy. Now what do you do?
Combine like terms.
Yep. So yeah, at the bottom first you have 3 times 10, so that's 30. And you have an isolated x. What do you do with this y and y? Is that y squared?
Yeah.
Okay. So the top, we put it all inside the radical. So 15 times 10. I was going to take a shortcut. 15 times 10 is 150. And you have this x times x is x squared, right?
Yeah.
Y times y is y squared. So there's a lot of good things you could do with this one. So what's the next thing you should do? What's the next thing you should do with this one?
Split the 15 into different parts.
The 150?
The 15.
Where's what you mean the 150?
Oh, yeah.
Okay. So what can you split it?
15 and 10.
I would probably start higher. What about 25?
Yeah.
So how many 25 goes to 150?
5.
6. It's like this is like quarters. Like like you have how many quarters goes into $1.50? 6, right?
Yeah.
Okay. So you have this guy times 6 times x squared times y squared. Okay, now what is this square? What's the square root of 25 now?
5.
Okay, good. So the square root of 25 is 5. So that comes out of the radical. Let me just write this carefully. And then you have this root 6. What about this x squared and y squared? You can take that out as well, right?
Yeah.
So it becomes x, y, root 6. And then the bottom stays as 30x y squared. Okay. This is good. What do you do now?
You could split 30. Wait, never mind.
You could cancel it. Yeah. How many 5s goes into 30? You could cancel it with a numerator.
6.
6. So it's 1 6, right? 1 6. Yeah.
Yeah.
Okay. What about the x and the y?
That comes out once.
So x is gone, right?
Yeah.
And then okay, so you have 1 6 y over y squared. So what is that? Y is at the bottom, right?
Yeah.
Okay, so you have root 6 at the top. Nothing's at the top anymore. And you have 6 y. Does that look right?
Yeah.
Yep, and that's the answer. How about those? Those are not that bad. You just have to like go through the process. They're not really that bad. Okay, let's try to go to the these guys now. Rationales. Okay, let's start easy. But always with variables. We're done with integers. We're gonna go to variables and integers now together. When you do 10n over 9 and you divide it by another rational, what do you do with the rational when you're dividing by a fraction?
You flip it.
And you multiply it, right?
Yeah.
You flip it and you multiply. So like this, 16 over 13n squared. Good. And then you just do the same thing as what you've done. So what do you do first? I mean, there's multiple things you can do. What would you do first?
You could cross multiply.
Okay. All right. I think the first thing I would do, be like, so that math is easy, is you can cancel these guys, right? I think, let me think if you can cancel anything. Actually, no, you can't cancel anything except for the n. Yeah.
Yeah.
So let's cancel the n, and you only have 1 at the bottom here, right?
Yeah.
So you have 160 divided by, what's 13 times 9? 7 to 117. I think that's right. And let me see if this is right. Okay, it's right. That's pretty simple. That's the answer. All right, let's do something more difficult. This is too easy. Let's go to 7. So same thing, right?
Yeah.
So this one would be, so you have 4n over n minus 6. And then what do you do?
Put it to multiply and then flip the second term.
Okay, and 4n, so like that. And now what would you do? Cancel the 4n, yeah?
Yeah.
So the n 4n cancels. Okay, that's the obvious one. So you have an 8n over 48 minus 48 over n minus 6. Let's see if we can take something out of the 8n minus 48. You can factor out something from that, right?
Yeah.
What can you factor out?
You can take out an 8 from 48, and because 8 times 6 is 48.
Awesome. So then it cancels, right?
Yeah.
I think that's easy. It's just 8. Okay. Is that even right? Seems pretty funny. Okay, it's right. Yeah, I like those ones actually. You get something very complicated, it just makes it very simple. It's the power of algebra. All right, let's do number 9. 7a squared over 7a cubed plus 56a squared. And what do you do with the second one?
Flip it.
Okay, and then so it's a squared plus 7a minus 8 over 2. All right. So this one's a little bit more difficult. What do you do first, or what would you do? Actually, you could have done something with the beginning one. This first one right here. Yeah, the 7, and then
yeah.
there's an 8. There's an a, I think, a squared.
Yeah.
So let's actually do that first. So you can take out a 7 and an a squared, and at the bottom let's see 7 and a squared cancel out with I guess this is just a plus 8, right?
Yeah.
So this is just 1, and then let's see, a squared plus 7a. Sometimes this polynomial up top, you can do something with this, but let's do it one step at a time. So you cancel this guy, right?
Yeah.
And then so you're left with 1 over a plus 8. And let's see what we can do with this top one. I think you can factor something out. Have you guys done polynomials yet?
No.
Okay. So something like this, just to like maybe talk about it, when you have like something a squared, this thing is squared, right?
Yeah.
And then this next term is like 1, a to the 1, and then this next one is nothing, right? There's nothing in here. It's just a constant. This is what you call a polynomial. Because like you can have like a series of variables that go from like 2 to 0. Technically, a to the 0 is 1, right?
Yeah.
So this is 2, 1 to 0. You can have a cubed plus a squared plus a to the 1 plus a 0. That's another one. And that's what you call whatever the highest number here is. This is what you call a polynomial to the third power, a third order polynomial. So whatever is the highest power or exponent of like this expression, for this guy, this is called a second order polynomial. More on that later. I just wanted to like tell you that. Yeah.
Yeah.
I mean, like you'll do it. We'll do something what you call like quadratic equation later on and quadratic formula, but that's later on. So, but what you could do here, let me think if you have to do this, is you could factor something out. Let me see if you can factor out a plus 8. So let me see. If you do that and you have like a, I think you can. Yeah. Because if you do this, a squared, try multiplying these guys. A plus 8 times a minus 1. That's a squared minus a plus 8a minus 8, right?
Yeah.
Have you done something like this before, like when you multiply these guys?
No.
Okay, I guess I'll show you. This one is a little bit, I guess it's like it's showing it to you, but then you haven't really covered it. But when you do, when you have like this kind of deal, like a plus 8, and you multiply it by like a minus 1, this is what you call foiling. And it's just so that you can simplify this guy. So let me show you how I did that. I kind of imagined that, like for example, this other guy is in the bottom, right? A plus 8.
Yeah.
So I presume that maybe I can cancel something out at the top, which is this guy, right?
Yeah.
So I'm gonna assume maybe I can divide that by a plus 8. So that's what I did. I assumed that there's an a plus 8 term, yeah? And then now what I have to do is figure out what this guy is. What is this guy? And what I mean by figuring that out is what can I do so that I can get a squared plus 7a minus 8. What can I multiply a plus 8 so I can get this guy? Does that make sense?
Yeah.
Okay, so let's kind of like look at that separately. So that's the main issue. That's the main goal, is what can I multiply a plus 8 to get a squared plus 7a minus 8. So let's actually remove this guy. So what you have to figure out is it's going to be kind of similar to this, and then you're going to have to see there's an a squared term here, right? Yeah.
Yeah.
So what do you multiply a so that you can get a squared?
A.
So that's the first term, yeah?
Yeah.
So that's easy. But now this, you're multiplying this together. So it's not just a squared, right? So let's see what happens. You have a squared here because you have to distribute this guy, don't you?
Yeah.
So when you distribute that guy, you have a squared plus 8a. You have an 8a, an extra 8a. But what do you have next? You have 7a, right?
Yeah.
How do you get 7a from 8a? What do you have to do? You have to subtract something, right?
Yeah.
What do you have to subtract it from to 8a to get 7a?
8 minus 7.
Okay, but then it has to have an a, right? 8 minus what gives you 7?
1.
So you have to minus how many a's from 8a?
1.
So it's just 1a, right?
Yeah.
Okay. Okay, we got that far. So a squared plus 8a minus 1a. But the thing is, I need to add something here to get minus 1a, right?
Yeah.
So let's look. How can I get minus 1a? What do I have to multiply this guy? Knowing I have to distribute it. It has to be something minus, right?
Yeah.
Minus what? Minus 1, right?
Yeah.
Let's take a look at if it works. If that was like, that's kind of like a way to figure out what is this guy. Because the main point is, what is this guy? So now that we think that we have this minus 1a, let's see if we can distribute it. Just that part. Because you have to do this like separately. So just distribute the minus 1 only. So let's see, minus 1 times a. That's indeed this guy, right?
Yeah.
But what is minus 1 times 8?
Negative 8.
Negative 8. Okay, I think we're done. So let's simplify. What do we have here? A squared. And then what is this 8a minus 1a? What is that?
Negative 8.
Positive 8 plus 8a minus 1a. What is that? Plus 8a minus 1a.
7A.
Plus 7a. And then minus 8, right?
Yeah.
Is that the same as this guy? That's the same, right?
Yeah.
And that's how you figure it out. So now, since that's the same, you obviously have the right one here, right? You have the right like things that are being multiplied. Yeah.
Yeah.
So this is equivalent to this guy. So let's just put that in the numerator. That one, what do you think of that? Is that confusing? We'll cover that again.
Not that confusing, but it takes a lot of steps.
Yeah, that's what you call foiling. That's all in the, once you see something like this, the polynomial, you have to do something like that. So you have a plus 8 times a minus 1, and going back to the original equation, over 2. So what can you do now? What can you do with this? You can cancel something, right?
The 8 and the 2.
The this guy, a
Oh,
plus 8, yeah,
yeah.
and a plus 8. That's the same, right?
Yeah.
So you can cancel that guy because they're being multiplied, top and bottom though. So I mean, this is just 1, so it just disappears. And then the last thing is simplify. A minus 1 over 2. And let's see if we get that one, number 9. Yep, that's what they get. This is the answer. a minus 1 over 2. Yeah, those are, let's cover more of these, because I know we didn't really cover like polynomials yet, but I think this what we're covering here, how we just did that, is just an extension of exponents. If you can do exponents, you can do a lot of things. So let's do this guy, number 11. This is a little complicated. So what do you do first?
Turn it into multiplying, and then
Okay.
flip the second fraction.
Okay. Before we even do that one, like I'm looking at this first term. It looks like we can do kind of like what we did here. Yeah.
Yeah.
So let's try to do what we did there. If we can like split this x squared plus 10x plus 16 and then x squared plus 6x plus 8. Let's look at something here. So let's see. You have this x. What is that?
You can cross out the x squared.
Not really. You can't. A lot of people think you can do that, but not yet. You know why you can't do that? Because it's being added, right?
Yeah.
If it's being added, you can't cross. You can't cancel because it's not being multiplied. Only when it's being multiplied. But what you have to do first is you have to do what we did here, where you split the a squared plus 7, 8. I'm just gonna rewrite it again. You have to split it to like a plus 8, and then a minus 1. Yeah.
Yeah.
And after you do that, if there's something at the bottom that looks like it's the same thing, that's when you cancel. But you can't cancel if it's being added. So you have to do this first. So let's do that. So okay, let's start with the easy one, the top. I guess it's like call that easy. So x times something. It's gonna be kind of similar. It's gonna be kind of like this. It's like x times something gives me the bottom. And I guess we'll do this one. So it's easier if we do this. Okay. I guess we'll take it out separately. What gives you? Let me just close it. When you do this, something like this, you have to take a look at this other side. So you have an x squared here, right?
Yeah.
So what do you have to put in this other one right here to get x squared? Because you have an x right here. You have an x right here. So you have to times it by what? An x, right?
Yeah.
So if you times it by x, you put it right here. And let's do them one by one. So now you have x squared. You have x squared because you have x times x. And the next thing to find is how do you get 10x? How do you get 10x? So let me see. Let's start with maybe adding something. Let me think if you can even do this one. Let me see. So that's 8 plus 2. Actually, let's not do that one yet. So the question to ask always is, these two guys are always related, is whatever is on the outside here, whatever is on the outside has to be multiplied to get you 16, right?
Yeah.
So what are the two things that you can, and this is the question asked, what are the two things you can multiply? Like maybe, because I'll just write it down here, the options that you have. These are only options you have. So to get 16. So all this gives you 16. But then the question is, what are the two things that you multiply that when you add them gives you 10? I know it's a little confusing right now, but this is usually the question you have to ask. So on the outside here, what do you multiply? 1 and 16, 2 times 8, 4 and 4. Gives you 16, but then when you add these two, 1 plus 16, 2 plus 8, 4 plus 8, or 4 plus 4. That when you add them, so this one is supposed to give you 16, and this one is supposed to give you 10. So let me ask you again, what are the two numbers that you times that when you add them gives you 10? Which one of these guys? Like what line? Is it this one? It's not this one, right?
No.
Is it this one? This one is 8, right?
Yeah.
So it's not this one. But what about this one, 2 plus 8?
Yeah.
So 2 times 8 gives you 16, check. 2 plus 8 gives you 10, right?
Yeah.
Okay. Yeah. Well, like I said, we'll cover more of this. I mean, it's good that this is showing up now, but this does get a little bit like weird. But that's the question to ask when you have to do this kind of thing. So it's this one. So it's actually the 2 and 8. So it does kind of matter sometimes where you put it, but in this case it doesn't because they're both plus. So I'm just gonna put 2 and 8 here, and then they're both plus. Let me just rewrite some things. And so, does that make sense?
Yeah.
Then let's just check. After we figured out this numerator one, let's just check if what we assume is correct after we actually multiply it out. So we have here x plus 2 and x plus 8. And this is how you multiply this usually. You do the first one first. You distribute the first one. So x squared plus 8x, right?
Yeah.
And then the second one, you distribute the 2. And so it's plus 2x plus 16, yeah? Right?
Yeah.
And then you simplify it, right?
Yeah.
So x squared plus 10x plus 16. It matches. That's good. Does this part make sense to how I multiplied it?
Yeah.
You start with like the beginning and you distribute, and you start with the first one, you distribute, and you add the second one, you distribute. It's just and then you simplify. That's the steps. Okay. So now we did the top, that's good. Let's do the bottom now. So what was it? You have x on the outside, and then what do you times x to get x squared?
X.
X. Good. Okay. Now the same question you have to ask. What two things that you have to multiply gives you 8, but when you add them, gives you 6? Can you do it mentally? Try tell me which two numbers you multiply that get when you add them gives you 6.
3 and 2. Wait, no.
You're almost there.
3 and 3.
The other one, you said 3 and 2. Which that's 6 though. What two numbers you multiply? 2 times what?
3.
Gives you 8. 2 times what gives you 8?
Oh, I thought you said 6.
Oh no, this one. What two numbers do you multiply gives you 8? When you add them, gives you 6.
2 and 4.
Good. So 2 and 4, right?
Yeah.
2 plus 4. Yeah, this meant multiply and this meant addition. So 2 times 4 gives you 8, and then 2 plus 4 gives you 6, right?
Yeah.
So that's it. So those are your two numbers. They're both positive. No issue. I'll tell you when there's an issue. Usually when there's one of these are negatives. When one of these are negative or both of them are negative, it's usually an issue. But for now, let's go with plus. Both of them are plus, and it doesn't matter where you put it since they're both plus. Make sense?
Yeah.
Okay. I'm not gonna show the checking, but it should be correct. Okay. Now that we're here, what's our next step now? Because now we pretty much split them, right? They're easier to cancel out now, right?
Yeah.
So what can you cancel out?
The X.
There's two things you can cancel out, right? What's these guys? They're the same, aren't they?
Yeah.
So they can cancel, right?
Yeah.
What else is the same? What else is it?
X plus 4.
Yeah, so this guy can cancel out. So you're only left with x plus 8. I think that's the answer. Yeah?
Yeah.
And that's it. And if this was an extension, maybe this is an equation. This could be like a 5-step equation. And maybe this is equal 10. You can just solve for x, right?
Yeah.
Yeah. So this is like everything, like pretty much before you do the, solving for x, this is like everything you have to do, the simplification. All right, let's do lines now. Maybe we'll cover that. We'll do more of that later on. Where's the line? What happened to the line? Oh, I think this is the one. All right, we'll just, oh, here we go. Here's the line. Okay. So we'll just make up our own things. I'll send you something once you guys are not covering it yet. That's why I'm not sending it to you. Just do the worksheets on radicals and rationals if you have time, and then maybe I'll send you some of these the line ones. Okay, let's take a look at what we did last time. So do you remember there's this y equals mx plus b, right?
Yeah.
And what was m?
The slope.
Yes, the slope. Actually, I think your dad was telling me that he remembers this one. the slope. And it's like, oh, the slope, because I was emailing him about this. And what about the b? Which one is this one?
The y
Intercept, right?
intercept, yeah.
Yeah, y-intercept. So b is y-intercept, and the m is the slope. And then this x and y are your coordinates, right? These are just your coordinates of your line that passes through to the line. So that's one. That's what you call, that's one form of this linear equation, slope-intercept. Slope-intercept form. The second one is called standard form. So there's a standard form. So like, what the heck is a standard form? Does that mean that slope-intercept isn't standard? Not really. It's just another way. They just, people just called it standard because it's the first one that they figured out. But the standard form is this is what it is: ax plus by equals c. This is a standard form. So this x and y are the same as this x and y. They're exactly the same. They're the coordinates of your line that passes through. This a, b, and c, these are constants. So what I mean by that, I think it's better just to maybe give you an example. These are just numbers, and then the question that always gets asked is how can you convert? How can you convert from the slope-intercept to the standard form? And sometimes it's the other way as well. How can you get the slope-intercept given the standard form? So let's kind of cover that in an example. So for example, what if you had like y equals like 1/2 x, and maybe your intercept is like 5, yeah? -5, right? So you have y equals 1/2 x minus 5. And then the question here is, how can I get the standard form? Like, I need to convert this to something like ax plus by equals c, right?
Yeah.
You can probably imagine how you would do that. Like, it's really just it's just algebra. So you need x and y in this side, right? In the left hand side, yeah?
Yeah.
So what do? You have x on the right hand side, you just transfer it over, right?
Yeah.
So what is that? Y, that's what? And keep in mind this is the form that you want. So what is that on the left hand side? Minus, right? 1/2 x.
Yeah.
Plus y, right?
Yeah.
Yeah. Actually, yeah, we'll do it either way. So when you do that, you have -5 here, right?
Yeah.
Okay. The one thing that they always ask you to do is don't have any fractions. Don't have any fractions. So what would you do when you don't want any fractions? You just times it by what? By the bottom, right?
Yeah.
So you times that by the 2, so you get all of it. So you get minus x plus 2y equals -10, yeah?
Yeah.
Does it look like this?
Yes.
And that's the one. This is the standard form. Now let me tell you why you need to do this. So when you have the standard form, it's easy to. Do you remember I asked you what is the y? Like sometimes they ask you what is the y-intercept? Yeah, they ask you what is the y-intercept, right?
Yeah.
And then I'll tell you again. You get the y-intercept by making x 0, right?
Yeah.
And then you have to solve for y. So let's do that. The reason why you do this standard form because it's easy to do this. Knowing what this is, you just make x 0, right?
Yeah.
So we make x 0, so minus 0 plus 2y equals minus 10. This disappears. So what is y? You divide it by 2, right?
Yeah.
So your y is minus 5. This is your y-intercept. This is your y-intercept. Yeah?
Yeah.
And then we didn't really touch on this, but if you can get the y-intercept, why can't you get the x-intercept, right? That's a fair question, right?
Yeah.
So if you can get y-intercept, what's your x-intercept? What do you think you have to do? Like for the y-intercept, you made x equals 0 and solve for y. What do you do with the x-intercept? Kind of like following what we have here. You make the y what?
0.
And what do you solve for?
X.
Yep. Same thing. Kind of similar. Not the same thing, similar. So y equals 0, solve for x. And then same equation, standard form. So looking at the standard form, let's make y equals 0. If you can see it, y equals 0. So minus x plus 2 times 0 equals minus 10. So minus x, this just equals minus 10. So what is x? X is 10, right?
Yeah.
And this is your x-intercept. And that's the main point. That's the reason why you want to change it to the standard form. The standard form gives you the x and y-intercepts clearly. They're easy to find just by plugging in x equals 0, y equals 0. Does that make sense?
Yeah.
Okay. I guess let's cover again how you. I guess that's just an extension. Let's cover what we did last time with like actually graphing it. But now let's graph it and then find the standard form and confirm what our x and y intercepts are. Let's see. Let's see if we can do something similar to what we did. All right. So we're given this g thing. It's just me writing given. So what we're given here is two coordinates. Let's say like maybe this is like 3 and then 1. And we're also given like let's see, like 5 and 2. Those are our coordinates. So this is x1 and this is y1, x2 and then y2. And then there's a line that passes through both these coordinates. And then the question is, find your line equation using the slope-intercept form and then graph it. After you graph it, give me the standard form. Give me the standard form. And I guess give me the next thing is so I guess we'll add another thing because like we already did that one. So that one, and then give me the x-intercept. And then ask for the y-intercept because you're gonna find that anyways. So let's do something like that. All right. So the solution or the answer is, do you remember how we found, like, given the two coordinates, how we found the slope?
No.
Okay, let's cover it again. So very first step, every time they ask you something like this, find the equation of the line, y equals mx plus b, is you need to find the m first, and the m is the slope. So the M is rise over run, yeah?
Yeah.
Rise over run. And then that's just concept, but then what is the equation? The equation for rise over run is you take your second y, y2, minus your first y, y1, which is your rise, and then your run is your second x, x2, minus your second or your first x, x1, and that's your run. Okay. Do we have those? Y2, y1, x2, y1, x2, x1? Do we have those?
Yeah.
Okay. So what are they? What's the top?
Y2 is 2
Okay, and then minus.
minus 1,
Cool. And then the bottom, x2 is,
5,
and then minus.
3.
All right. And that's it. It's really simple. If you know this equation, you got everything. So m equals, and you simplify this, 2 minus 1 is 1. 5 minus 3 is 2. So it's 1/2. Your slope is 1/2. The next thing is find the y-intercept, or b. B is the y-intercept in the slope-intercept form. So this is your y-intercept. So how do you find your y-intercept? We talked about this. It's kind of this is like the same thing all over again. You find your y-intercept by what? Making x equals 0, right?
Yeah.
Let me see if this is the one that you're supposed to do it. Actually, that's what you do. X equals 0 if you have the if you have the equation of the line. Like if you're given points, you could just write this equation first. Y equals mx plus b. You already have m, right?
Yeah.
So this is y equals 1/2 x plus b. And remember, b is the one you're trying to find. And y and x, these are just coordinates of the line, right?
Yeah.
So let's use one of them. Let's plug in one of the points because they're supposed to lie. The line is supposed to pass through the point, right?
Yeah.
So let's make x 3 and then let's make y 1. So y is 1 equals 1/2 and then 3 plus b. Yeah?
Yeah.
So that's 1 equals 3/2 plus b. Solve for b. 1 minus 3/2 equals b. That's just 1.5. So 1 minus 1.5 is just minus 1/2, right?
Yeah.
Minus 1/2. And that's your y-intercept. So now you have your m. Now you have your b. You can write the equation of the line. So that's pretty much y equals m, which is 1/2, x plus b, but it's negative, so it's negative 1/2. So that's the equation of your line. And now let's graph it. Let's graph the line. So let's see. So this is y, this is x. And then so we have three coordinates, right?
Yeah.
And what are they? You have 3 and 1. You have 5 and 2. So that's given to you. But you also have the y-intercept, right?
Yeah.
And y-intercept is when x equals 0. And y is the intercept value, or the b. So minus 1/2. So you have 3 coordinates. All you have to do is like plot them. So let's see what we should have. 1, 2, 3, 4, 5. And 1, 2, 3, 4. 1, 2, 3, 4. -1, -2, -3, -4. 1, 2, 3, 4. All right, first one. 3x and 1y. And the next one, 5x and 2y. And then the last one, 0x negative 1/2 y. Can connect the dots. Okay, if I can do that. And that's it, right?
Yeah.
So that's not that bad. Okay, that wasn't new, that's why. So let's talk about this new one. So what was the other one? You need to find the you need to find the other form, right? The standard form. Yeah?
Yeah.
The ax plus by equals c. So how do you do that? We kind of covered that briefly. Let's do it again. So let's just, what you want to do here first is write the slope-intercept form. Y equals 1/2 x minus 1/2. Slope-intercept form. So you want to convert this into ax plus by equals c. What do you do first? What do you do with this one? It's kind of like what we've been doing. So like manipulating equations. How do you get x to the left side?
Make it a negative.
So you minus 1/2 x both sides, right?
Yeah.
So minus 1/2 x plus y equals minus 1/2, right?
Yeah.
And then what's the rule? No fractions, right?
Yeah.
So what do you times this? You times it by 2.
Oh yeah.
Or like 2/1, whatever. If it was like not 1/2, like 3/2, 2 over something. So you times it by 2, and then you get minus x plus 2y equals minus 1. Are we done? I think we're done, right?
Yeah.
It looks like this guy now. So this is your standard form, and this is your slope-intercept form. It's really good to go, like from slope to standard and standard to slope. Going to slope to standard would cover it, but then standard to slope, you can just turn this to this guy easily, right? You can just
Yeah.
move. You can isolate the y in essence. That's what it means, right? You move everything to the right except for y. That's it, and you get your slope-intercept. Okay. Now the fifth question. Find the x-intercept. And how did we find the x-intercept? What does that mean? That means that y equals 0, right?
Yeah. And then solve for x.
Solve for x. So let's do that using the standard form, because that's the purpose of why you do that. So minus x plus 2 times 0 equals negative 1. So this cancels out, and you have minus x equals negative 1. So what is x? X is 1, right?
Yeah.
X-intercept. This is your x-intercept. So don't forget, this is not really the main x, but this is just your x-intercept. And if someone were to ask you graph your x-intercept, it's harder to graph something with I mean, it's not that bad. I really prefer creating the slope intercept versus the standard form in terms of graphing, because for the most part you could always graph something using the standard form, but when you have the slope intercept, it's so easy because you know the slope here, right? And then you know the where it crosses the y-axis. That's just b, right?
Yeah.
And this is m. We'll cover the one like later where you if you're given the standard form, how can you graph the line? But for now, let's do another one. Let's see. So let's do another one just so like more practice. So like let's do this guy. So given 2, 7, and then like let's say 3, 3, 5. And this is your x1, y1, x2, y2. Find me, and I think we'll make this the last one. So find me the y equals mx plus b. Also graph it. Give me the ax plus by equals c, and the x-intercept. These are the typical questions that usually gets asked. So what's the very first step? Given the two coordinates, what's the very first step?
Put them in a fraction.
Okay, like the slope, the equation, right?
Yeah.
Find m, or the slope. So it's always good to like, always repeat, because then you remember it. So m equals, what was m again? Rise over run, right?
Yeah.
And then what's the equation of this guy? y2 minus y1, right?
Yeah, over x2 minus x1.
Okay. And do we have those?
Yeah.
Okay. And you're probably wondering, does it matter which one is x1 and y1? Sometimes it does, but for the most part, whichever one they give you first, that's the y1 and x1, and whatever second is usually the x2, y2. And okay, so what is your y2?
5.
5. Okay. And what is your y1?
3.
y1?
Oh, 7.
Okay. So it's minus 7, right?
Yeah.
And then what is your x2?
3.
3. And what is your x1?
Negative 2.
Minus 2, right?
Yeah.
Okay. Oh yeah, we didn't really cover negatives yet. Maybe I should do that, because then it will mess with your slope. We'll do that next time. And we're taking it really step by step. All right. So 5 minus 7 is what? Negative 2.
Yeah.
And 3 minus 2 is 1, right?
Yeah.
So your slope here is minus 2. Good. Now tell me how to find. What's the next step after the slope? Find what?
X.
The b? Find b, right?
Oh, yeah.
And what is b?
Y-intercept.
Okay, y-intercept. Okay. M is slope, b is y-intercept. These are very important, because this is pretty much the essence of the line. So how do you find b using the y equals mx plus b? You rewrite it, right?
Yeah.
And then plus b. And then what are these x and y's? Any of these guys, right?
Yeah.
You could either use this or this. I usually look at, like, sometimes whichever one's easy, and then if there isn't one, I just pick the first one. So plug in the first point. So what is y? What is y in my coordinate?
7.
Okay, 7 minus 2 times what? What's the x?
2.
2. Okay, plus b. And then now you just solve for b, right?
Yeah.
Okay, minus 4 plus b. So plus 4 plus 4. B equals 11, right?
Yeah.
So m equals minus 2, b equals 11. This is going to be a big graph. So let's actually write the equation of the line first. The equation of the line, since we have m and b now, is y equals minus 2x plus 11, right?
Yeah.
That's the slope-intercept form. So what's the third step?
Solve for x.
We have to graph it first, right?
Yeah.
Let's graph it first. We can solve for x if we're doing the y-intercept form, or the The x-intercept, I meant. The x-intercept. We'll do that last. So find graph or this graph. Okay, let's take a look at this. Because we're given 3 points, right?
Yeah.
And what are those points?
2, 7.
Okay, and then the second one?
5.
3, 5.
Yeah.
3, 5. And then what's the third one? What's the third point?
11.
But what's the x though?
2, negative 2x.
No, like this is the y-intercept, right?
Yeah.
And what does that mean for your x? 0. Yeah?
Yeah.
And what is your y?
11.
Yeah, that's what that means. When you see the 11 right here, it means you have a point that's 0x and 11y. That's what that means. I always say that because like sometimes people are like, oh, we have a third point? Okay, now we can graph it, right?
Yeah.
So let's see. Our maximum x is 3. Let's make the y bigger. So let's do the y first. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11, 10, 9, 8, 7, 6, 5, 3, 2, 1. The next one is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, that's enough. So first point, 2, 7. So 2, 7. Good. Make it big. And the next one is 3, 5. 3, 5. This looks like a negative slope, yeah?
Yeah.
And can we confirm that one?
Yeah.
We have a negative slope. So it's, the line tells you kind of like behaviors of the line, right?
Yeah.
It's supposed to slope down because it's negative. And then where's the last point? 0, 11, right?
Yeah.
So 0x, you go all the way up here where it crosses the y axis. And I think you're good. You can just graph it now. It's easier to graph this one if you have like a graphing paper, but just doing my best here. So now just connect the dots. Connect the dots. You have this guy. And that's it. This is your line, right?
Yeah.
This is y minus 2x plus 11. That's your line. And then m equals negative 2, which is your slope. B equals 11, which is your y-intercept. And then B is right here. M is this guy. Okay. That's really the essence of the line. Like if you can do up to that point, you're really good to go. Like halfway through like algebra, really. And everything else is just solving for like quadratic equations and all of that. All right. And then there's word problems, which I think is like one of the best ones because then you can apply it. So the fourth thing to do here is find the standard form. Find the standard form. AX plus BY equals C. And how do we do that? We write the slope-intercept form first, right?
Yeah.
So y equals minus 2x plus 11. And then how do we get the standard form? What will we do first?
Solve for x.
Okay, so we need to transfer the x, right?
Yeah.
So how do we do that? Transfer it to the left. What do we do?
Plus 2x.
On both sides, right?
Yeah.
And then you just pretty much follow where the x is first. So I like to put that first. And then plus y equals 11. Are you done?
Yeah.
There's no fractions. So this is good. So this is the slope-intercept form, and this is the standard form. And you should try to, go from one to the other. If you were to go from this guy to this guy, it's really simple. I'll show it to you really fast. Pretty much reverse your steps. You minus 2x minus 2x, right? So y equals minus 2x plus 11. Easy, right?
Yeah.
It's not that hard. If there's a fraction, you may have to do some other things, but it's not that hard. So, okay. And the next thing is find. I guess we'll add another dimension. We already found the y-intercept, but let's find it again. So find the x and the y-intercepts. How do you find the x-intercept? How do we find the x-intercept? You plug in y equals 0, right?
Yeah.
And then you solve for what?
X.
Okay, so let's do that first. And so we have this guy, 2x plus y equals 11. So let's follow exactly what we said. Plug in y equals 0 equals 11. Solve for x. Okay, 2x equals 11. So you solve for x, right?
Yeah.
So x equals 11 over 2, or like 5.5, whatever. All right, so what about the y-intercept? How do we find the y-intercept? Not using the slope-intercept. Slope-intercept form, you can just read it. It's right here, right?
Yeah.
But then the y-intercept in the standard form is it's not hard. It's the same exact thing as what you did here. So what do? You plug in what?
X.
Equals what?
11.
X equals 0. Yeah?
Yeah.
And then you solve for y, right?
Yeah.
Okay, using the standard form. So let's do that. So 2x plus y equals 11. Let's do exactly what it says. Plug x equals 0. So 2, 0 plus y equals 11. Do we have our answer? It's really simple.
Yeah.
Y does equal 11. So yes, the standard form gave us the same answer, right? As the
Yeah.
slope-intercept form, which it should. It should give you the same answer. But the one thing is, you can find the x-intercept in the standard standard form. You could also find the y-intercept in the slope-intercept form. I think you should be able to do that, right? The same thing. It's just plugging in numbers, solving for other things, right?
Yeah.
Okay. So yeah, that's pretty much everything that we should do today. Just try to. Does that seem simple? What we just covered right here? Or do you want to cover this more?
I think it's good.
Okay, let's cover it more, just a tad, to review it next time, and then again and again. Obviously, you guys haven't touched on this yet, right?
No.
So that's why I'm just covering it until you guys finally touch on it, and maybe we'll do. Yeah, we'll put off the other stuff because I wanna repeat this as many times as possible, and then maybe we'll do something like with the negative coordinate, because we only have positive coordinates here, right?
Yeah.
Maybe we'll do one with negative coordinates, and then inequalities next time. Cool. All right, Milo, I think that's it, and then have a good week.
Bye.
All right, cool.